Hello and welcome to this episode of Stratola Spectrum. I'm your host, Dinesh Chandrasekhar. In this episode, we're going to be speaking with Shuveb Hussain, who is the CEO and co-founder of Unstract. Shuveb is a serial entrepreneur, and he has been an engineering leader at several companies like Smartron and Freshworks prior to founding Unstract. So thank you so much for joining us, Shuveb. Appreciate it.
Thank you for having me here, Dinesh.
Wonderful. So why don't we start with you introducing us to Unstract? This is the company that you've been running for the last couple of years. Tell us more about Unstract. Why did you start this?
Right. So, Dinesh, you take, any modern data stack, right? What should it have been ideally? Let's think about that for a bit, right? It should have worked irrespective of what data you threw at it, right? Irrespective of where the data would live, right? Now, data in any enterprise data is in silos, but then another great problem is, hey, of course, we have the stack for dealing with structured data, but what happens when it comes to unstructured data, right? The way we look at it is, when it comes to unstructured data, there's a couple of ways to deal with it. When it comes to simple unstructured data, like let's say a copy of a passport or a form, a driver's license, things like that, there's various solutions, what known as IDP solutions, right? Intelligent Document Processing Solutions. And for more complex documents that are contracts and, longer documents with more natural language, right? You quite literally just have to deal with them completely manually, right? So you have this like a two levels of unstructured data processing in today's modern data stack, right? Which means that nothing actually happens on the data stack itself, right? Now, what we are trying to do is we are trying to say, hey, we are unstructured data ETL, right? So you have a bunch of documents, you throw them, let's say, into S3. How can they appear in, let's say, in a structured format in let's say, Snowflake or Redshift or BigQuery or where have you, right? That's the problem that we've been solving,
Mhm.
right? So yeah, that's in a nutshell, that's what we do.
It's practically workflow automation for unstructured data. Is that how you would think about it?
Well, the automation bit, I think, comes after the structuring happens, so we don't really venture there. So think of us as more of an ETL tool or as an API to extract structured JSON from unstructured documents, irrespective of how many variants are there within those documents. For example, let's say you get bank statements from 100 different banks. They're all going to look in 100 different ways, right? Right? But how do you manage all these variants and yet have structured data in a common schema? That's the only problem we solve. So we always sell to the engineering team. So the automation bit happens after the structuring is available, and that's more of a vertical problem to solve by the particular customer that's buying the solution. Yeah.
Wonderful. So talking about verticals, are there any specific verticals where you see this kind of getting more traction than the other? Can you tell us a little bit about use cases where this is more applicable?
Yeah, absolutely. So, what we found is, Dinesh, as we started selling Unstract is if you, yeah, of course, we started with line of business users, but then we realized that it's more the engineering teams that want it because they're okay with the platform more, right? But the pattern we are seeing is probably, let's say, 60% BFSI, banking, financial services, insurance, and then a little bit more, maybe around 25% or so healthcare, and then it's a long tail, right? So what we are seeing is whenever a regulated business, more than anything else, interfaces with the outside world, they can't control what kind of documents they get,
Right.
right? And then, hey, that's where there's maximum use for a platform like Unstruct.
Right. Unstructured data is not new to this world. I mean, it's been there around for quite some time. We just like woke up to the fact that there is so much unstructured data because now AI and LLMs kind of have taken over the world, and suddenly we
Yeah.
have this potential to like tap into that.
Yeah.
So, considering that, how have people in these industries been leveraging unstructured data or trying to tap into such unstructured data so far? Like, what have been the kind of toolings and solutions so far that industries have been adopting, but now suddenly they have newer capabilities like Unstract that have come about, right? So, what has it been so far?
Yeah. So, Dinesh, I think, like I said, there are two levels of unstructured data, right? So, there are existing incumbent solutions that can process simpler documents without a lot of effort, like let's a little bit of manual annotation, and then you can process forms, and, they might have pre-built solution for more common document types like passports of various countries or driving license of various states in the US, things like that, right? But the reason why a huge BPO industry exists is because many of the documents just cannot be processed without large language models. And with the advent of LLMs, it's there's a lot of disruption going on, right? So yeah, it's pretty manual, or there's IDP solutions that can handle a certain types of documents to a certain level. Yeah.
Right. So since you mentioned IDP a couple of times, I think we need to kind of double click into that a little bit. Intelligent document processing has been kind of part and parcel of robotic process automation or whatever it has been termed in the past. That industry has kind of changed its name quite a few times over. But IDP is the ability to, as you said, process these documents that are either scanned documents or faxes or digital documents that come in through, and then be able to extract information out of it.
Yep.
There have been like older OCR technologies that have worked in the past. Again, if the structure is like predictable, if the XYZ coordinates match for a particular field and you're able to extract stuff out of it, yes, it works. But then, as you rightly said, the document structures don't adhere to the same formats, and
Yep.
scans can happen in like whatever ways and so forth. So IDP by itself has undergone a little bit of an evolution revolution by the advent of LLMs, right? So can you
Yep.
talk about maybe how LLMs have impacted this industry and how companies should look at IDP going forward?
Right. So IDP is still, machine learning and NLP based as it exists today, right? And of course, it will get impacted in a huge way by large language models, right? But imagine this, right, Dinesh? Let's say you get like, let's say, three different credit card statements from three different banks, right? Now, as a human, you can instantly recognize, hey, this is what I need to pay this month, right? You're not looking at, when you open the statement, you're not looking at, oh, I need to find what I need to pay on the top right corner. You don't care. As a human, you simply open the statement, you just read it, and then you figure it out, right? The amazing thing is, large language models process information in exactly that way, right? Whereas that's why I kept telling that, hey, there's no need for manual annotation as far as large language models are concerned, right? So that's a huge disruption right there. Now imagine use cases in which for a particular document class, you can expect a lot of variants. It's not easy to process it using traditional IDP systems, right? Whereas for LLMs, because they process language very much like how humans process language, or with the same capability that with which humans process language, there's just no need for that, manual annotation anymore. You ask a question and it's going to answer, and then you kind of figure out, for example, hey, a schema in your mind, and it can quite literally just give you JSON data, right? So that's a humongous disruption for IDP in general, right?
So it also brings up the question when you talk about LLMs, then you also have to address a few things, like, for example, accuracy and cost and optimization and things like that, right? So can we take it one by one? Maybe talk about the accuracy part first, right? How accurate can LLMs get when it comes to like these kinds of complex documents? And what are some of the things that we need to do in order to make sure that LLMs can process these documents in a more accurate way? Like, is there some kind of data preparation that needs to happen before you feed data into such LLMs?
Absolutely, Dinesh. You're 100% correct. So what happens is that the quality of the input actually matters a lot, right? Of course, you have vision models, but then they can only hold so much context. So even today, if you're looking to process longer documents, you need a service that can extract raw text out of a variety of documents. For example, native PDFs, PDFs that are scans, handwritten documents, smartphone click photographs of documents, all
Mhm.
sorts of things really. So you first need that pre-processing step, right? And then you need to represent information in a manner that large language models can best understand. For example, how are you going to represent tables? How are you going to represent checkboxes and radio buttons, which are commonly part of many different forms, even the more simpler forms, right? So that is super important, right? So that pre-processing step is super important. And as of today, this may change in the future with the vision models becoming cheaper. Text is a lot more efficient than processing pixels at this point of time. You can pass a much longer context to a large language model relatively cheaply, and then you can expect relatively more accurate answers. So that's the first step that you were referring to, and you're 100% correct, right? Now that pertains more or less to the complexity of the just the input documents that we see. Real world documents can be very, very complex, right? And then our philosophy is that at least with Unstract, right, we have a technology called layout preservation mode, where we preserve the layout of the input document by inserting various amounts of spaces, maintaining column layouts and things like that. Now, I don't want to make this like a sales pitch or anything, but then what we're trying to do is that moving the smarts to the large language model side. Don't be very smart while extracting the text. Just maintain the layout. If whatever you see, handwritten text, convert it. Checkbox and radio buttons, convert it, but into regular ASCII text. But then don't really have a lot of smarts apart from that, right? And then move the smarts to the large language model, right? Then comes the actual LLM accuracy part, which is the second part of the
Mm-hmm.
question, right? Now, the trouble with large language models is that they can hallucinate, right? And then, of course, I'm just going to assume that someone is using a flagship model like 4.0 or O1, or for example, even Claude Sonnet 3.5, things like that, right? Now, they can hallucinate. Of course, there's a bunch of techniques that you can do to reduce hallucinations, but you don't know if a hallucination occurred or not. The problem with hallucinations is, Dinesh, there is no programmatic way of determining if a hallucination occurred. That is the challenge, right? So we've taken a different approach. What we are trying to do is we try to look for consensus. We don't try to look for a certain value, right? Now, what we do is that we will let two large language models converse, and we will try to direct them to come to concurrence. If they do come to concurrence, then we will accept the answer, right? Otherwise, we won't. This mechanism, our philosophy is that a null value is better than a wrong value. So we simply either go with the value for which concurrence occurred, or we simply say sorry, we couldn't extract. That's probably better.
Okay. So that's a great response, and it sparks off a few other questions as well. One is from a optimization perspective, since you spoke about how text can actually be a much greater way to feed into LLMs, and how you preserve the layout of the text and all that.
Right.
What if the PDF is like really large, particularly when you talk about insurance and mortgage and those kinds of industries? We're
Yeah.
talking about 60-page, 100-page kind of documents, right? So
Yep.
does that challenge one from a context perspective, such large documents being fed into LLMs, or from a speed and accuracy perspective, does that deter as well? Or, as you pointed out, if you are trying to extract basically the text out of it, from a preservation mode
Yeah.
model, how long would it actually take in order to do a 100-page document before you feed it into an LLM?
Yeah, that's a great question, Dinesh. Right, that's where vector databases come in, right? So here's the thing, right? When you look at extraction use cases, you need to think of it from a business perspective, right? Now, generally, what people will do is that they will use some kind of a RAG technique, right? Retrieval augmented generation, where a document is basically, chunked and then sent to a vector database. And then first a question is asked to the vector database so that, chunks that might contain the answer are retrieved, and then along with the prompt as to what to extract, the chunks are sent to a large language model and the answer is extracted. The problem is the weakest link in this particular technique is that a vector database may not understand your question, right? And that's really the weakest link. A vector database understands words but then the semantic meaning of the word and nuanced prompts and all that, right? Vector dev is not going to understand. It's returning an approximation of what, hey, these chunks might contain the answer, right? So you have to take a step back and think about, hey, this is a business case, and for each extraction, let's say a bank is spending, a human has to spend, let's say, 4 hours trying to parse a bank statement which is 10 pages long, right? That versus I'm going to not chunk, send the whole raw bank statement context to a large language model and extract what I need. If that's going to cost you a little bit more, maybe it's going to cost you, let's say, I don't know, 50 cents. That's very acceptable, right? 4 hours of someone's time versus
Right.
50 cents. It's very acceptable. So while it might look like, hey, why are you not chunking, right? And why are you sending the whole bank statement to a large language model? We're not looking at achieving an award for low cost. How can I drive the cost down? We are comparing it against what does it take today to basically do this whole work manually. That's what we're comparing against. So we want the highest possible accuracy, right? But coming to your exact question as to when documents get longer, what really happens, right?
Mm-hmm.
When documents get longer, the the chance that the whole document might not fit into the chosen large language model's context just goes up, right? In that case, we just don't have a choice. We will chunk it up, store it in a vector database, then get the list of fields that need to be extracted from the user. Then we will do a retrieval, then send it to a large language model. And then the problem is that when you do this, the cost does decrease, but then the chance that the answer may not be very accurate also goes up.
Mm-hmm.
So that's the kind of what do you call, like, a trade-off you have, in these situations. Yeah.
Talk about the costs as well, because that's the other factor that I wanted to discuss as well, right? So everybody in today's world has like some form of AI tool or the other, and they're all excited about the boost in productivity, efficiency, and everything. And some of the
Yeah.
benefits that you talked about as well are like fantastic, right? So if I can do something with LLMs that'll take me 4 hours otherwise, and I
Yeah.
can do that like in a matter of seconds, I
Yep.
want it, right?
Yep.
Definitely I can see the cost savings in terms of like me working for 4 hours versus like,
Yeah.
getting that in a few seconds. But there are also hidden costs and implications when you start using LLMs. And I don't think the larger world actually understands how much it actually takes to run LLMs in your infrastructure and so forth, right? Or even if you leverage a service like yours, what the cost would be, right? So maybe if you can double click on that and explain what are some of the cost comparisons that you've seen? How do you optimize for some of these things, and how do you help your customers? I think that'll be helpful.
Right. So, Dinesh, when it comes to cost, right, there's a couple of things also you need to think about, right? See, we look at any extraction, the prompt engineering part as a software engineering problem, right? And we have to do that, right? So, for example, let's say you have to extract, let's say 20 different fields from a credit card statement, right?
Mhm.
Now, what you could do and what could be very efficient is write a single prompt where you describe a very large JSON schema, and then you have the whole extracted raw text from the credit card statement. You can run the prompt against that statement, and then you can get an answer. But the problem is, let's say you want to make sure that this prompt actually works across 15, 20 different variants. You're tweaking at one place in the prompt, and then it breaks for other statements in your
Mhm.
sample set, for example. Right? Typical regression, right?
Right.
Now, this is a bit of a headache for you because as a software engineer or a prompt engineer developing these prompts, you wish you had one prompt per field. But magically, when you wanted to do the actual extraction, everything was combined and then run against the full context exactly once. That is what we call single pass extraction. It's a feature in our platform. But here's the thing, right? As users, they only worry about an individual prompt for a particular field. So they can worry about, hey, how is this prompt performing across these sample variants I have? So we have a feature called coverage. You can go test, for example, what is the extraction per document variant, things like that, right? But what we do is we have access to large language models. So we use the large language model to combine all the user prompts into a single prompt, run it against the full context, right? This is one way of doing it. This is one cost saving feature. And
Right.
there's another cost saving feature called summarized extraction, where we will, based on the prompts, we will create a summary of the input document, run the individual prompts against the summary, things like that, right? So I don't want to go into the technical details, but enough to say that, hey, you're 100% correct that even when you're saving cost vis-a-vis using humans, LLM cost can add up very, very quickly. So every token that you can save, which is sent to a large language model, is going to save you in the long run, right? And for example, right, I mean, we process documents at scale. We currently process around 7 million pages a month. So every token saved is going to impact, right? So this is where I think, forget about Unstract, even prompt engineers who work on such projects, they need to really think deeply about, hey, how can I shave off tokens that are not required, right? How can I use a large language model to determine that? It's still, can I use a smaller model to figure out which portions of the document I need to send? And then finally use the model that I need to use for extraction. They'll still end up saving a lot of tokens that are sent to an LLM.
I think there is a complete entire business space there that
Right.
can happen. Sure.
Yeah.
Um, so having said that, I just
Mm.
want to explore a little bit about your thoughts on the larger LLM space today, right?
Yeah.
As it has been evolving, like almost every week we get like a new release from one of these guys that we just announced a brand new LLM and all that.
Yeah.
Have you seen the costs significantly come down? I mean, obviously the performance and the context windows have been like exploding like crazy week after week. What about the cost angle? Have you seen like these combined costs from these LLMs kind of going down?
Oh yeah, totally, Dinesh. Costs are definitely going down. When we started out, I think in May 22 is when we started working in earnest on Strack, right? And since then, I think the cost actually dropped 4x in case of, for example, GPT models, right? So I think the costs will continue to go down, and we are more excited about vision models, right? So see, here's the thing, right? Think about what LLMs can solve for today, right? Let's say it's a small circle, right? And what they can solve in the near future is a slightly larger circle. But ideally, right? So today we spoke about, for example, how can we are worried about a context window. An ideal LLM should have an unlimited context window. Ideally, I'm saying, right? It's not going to happen, right? And you should be able to throw anything at it, and you should be able to ask any question at it and then say, hey, I want, here's a document, I want this particular JSON output, or I should be able to throw a video at it and say, let's say it's an interview, and we should be able to ask, how did this candidate do, how were her expressions, and we could have asked, was she nervous, we can ask anything and just have a JSON output, for example, right? That's not going to happen, right? But even today, when we've had the prospects reach out to us and say, hey, I have financial documents, these have bar charts and line graphs and things like that, and then they've used some kind of a vision model and it's not working, and we've tried and it's like 40% accuracy, which is not good enough for us, and things like that, right? We are seeing two things happen in parallel. We see the prices dropping, but at the same time, these models are becoming better and better at output consistency.
Hmm.
So, for example, there's this variable when you talk to a model called temperature, which basically determines how creative it is, right? We always set it to zero because we want JSON output, which is very predictable. Even with zero temperature, if you run the same prompt twice, you might get two different answers, two different responses, right? But that is going away. We are seeing that with newer models, they are more consistent. They are able to understand more complicated prompts really well. The funny thing is, in this particular space, in our particular space, right? And Claude Sonnet 3.5 beats GPT models very, very routinely.
Oh, okay.
Yeah. Now, one explanation is that they're probably using more business data to train their models, but They're just very good at understanding things like tables and, let's say, columns that are fused together, rows that are fused together. I don't know how, but they're just really good at it.
Very cool. Good to know. Good to know. So you spoke about two things which excited me. One was the multimodal LLM,
Right.
concept. I think, that's an area that I'm very excited about as well. I think
Right.
when that starts happening through
Yeah.
a video, through an audio file, and being able to extract information out of it, I think
Yeah.
that is fantastic. One of the questions that I recently got asked, in this context of like working with LLMs and all that,
Right.
I was talking about data leakage, sensitive
Right.
data leakage from into LLMs and thereby from LLMs into like the external world. How do you prevent that is something that I was discussing. And somebody asked me, can you prevent like or detect sensitive data within video files, within audio files, and all that? Definitely, that's kind of like the future which you are hinting at. Where we will be heading to. But
Yeah.
just purely from a text perspective, when you talk about sensitive data leakage, particularly when you talk about bank statements and things like
Yeah.
that, um, where should the buck stop when it comes to like protecting that kind of information
Mm.
from getting leaked into LLMs? Because the moment it goes into LLM, somebody can do a prompt injection and like get that data out very easily. So how do you think about it or view that particular space from your vantage point?
So, you can straight away stop PII from going to LLMs as one solution if people are comfortable with that. Because sometimes, we see that customers handle data belonging to their customers, and there are contractual obligations in place where, they're not able to send the data to any third party. In fact, what I'm hearing from many customers who are, let's say, in the SaaS business is that, hey, if we now when they sign contracts, they are seeing clauses where it's clearly stipulated that, hey, you cannot send our data to a large language model.
Mm.
And they are saying, hey, this is becoming a big problem for us, things like that, right? So, of course, we partner with another startup called Protecto, where their expertise is really, hey, they can look at any input document or a prompt, and they can either anonymize, and basically reverse when it comes back, so that or they can even mask, PII, right? That can happen. That's one thing. The second thing one you can do is, earlier what used to happen is that OpenAI was, let's say, the a very powerful game in town. So even if you were on AWS, for example, you had to send your data over to OpenAI, which means that it was crossing over the AWS network boundary, right? But what happened later on is that AWS introduced, for example, Bedrock. Google has Vertex AI, and of course, Microsoft has, the Azure OpenAI service, and they even have like a Bedrock-like equivalent there, where they are tying up with many different large language models, and then they provide access to their customers. They are running these models. Like, how is it different? Let's say if you're using on AWS, using the database service RDS or S3, for example, AI is just another service.
Right.
Some customers are okay with that. They're okay with that, right? A few others who we talk to, some prospects, they are like, oh, we need to run large language models on our own. Like, we're not gonna trust, let's say, Bedrock or what have you, right? And what they're still on the cloud though. So what they want to do is that they want to run, let's say, open source models, like, let's say, Llama 3.2, and run it on a GPU instance. The problem is, what we are seeing is that some of these large GPU instances are capable of running models, let's say, that are 400 odd million parameters, like the Llama 3.2 models, the larger ones, right? They first is they might cost you a few $1,000s a month to run.
Oh,
So you
okay.
need to have sustained load in order to justify that cost. That's the first thing. The second thing is, so Dinesh, the GPT models are purported to be 1.5 trillion parameters. So comparing that to a 400 and something million parameter model, I mean, that's the problem, right? So when your prompts get very complex, even the largest of the large open source models may not work.
Got it.
I'm talking about extraction use cases.
Yeah, yeah, yeah.
These models could do summarization well. these models could write you a write-up or create content for a website. That's not a problem. For use cases where you're trying to convert unstructured data to structured data, the best of the best open source models are not that great, except for very simple, very, very simple use cases. Yeah.
Wonderful. Thank you. So last question. Thank you so much for entertaining me with all your wonderful responses. So last question is, how do you see, or what are you excited about in this particular space that is bound to happen in the next year, particularly with so much noise in the US, about like $500 billion being pumped into AI and all that. I want to understand, what do you see as like the next exciting thing in this particular space?
Right. So Dinesh, I think what we are seeing is that, hey, we're constantly looking for what are monetizable large language model use cases, right? So startups have shown us that enterprise search is a monetizable use case. Again, startups have shown us that coding assistants are a monetizable use case. Now we are showing that conversion of like unstructured data ETL to structured data is a monetizable use case for large language models, right? Because a lot of investments have gone into creating these large language models, and for good or bad, large language models are actually looking more and more commoditized, right? Unless of course you have specialized models. So I'm super excited for vision models that become a lot more accessible, have bigger context window sizes, right? But then I'm thinking, hey, when I think about, hey, monetizable LLM use cases, can agents become that, right? So now we have the data now to basically activate this data, put this data into action, having, hey, these models, these agents that of course use large language models underneath. But for very vertical, narrow use cases, we know that agents don't work very well for very broad use cases. That's when people are chasing AGI to do that. But I think that will start becoming a reality. Hopefully, this year is what I'm thinking, right? So yeah.
Wonderful. So with that, we'll wrap this up. Thank you, Shuveb. Thank you so much for joining us on this episode. Appreciate your wonderful insights into the space and talking about Unstract. Have a wonderful day.
Thank you for having me.